escape character to do a multi-line. That's going to really come in handy. Remember, if you just do a single quote or a double quoted string and you're in the interpreter like I am, you're going to have problems with line wrapping and getting a feel for where you are. So a good tip is to do the triple quoted string. That way you can press enter to your heart's content. I capitalize my SQL statements just by habit of convention. You don't have to do that if you don't want to. I'm going to create a table called emp, very basic table to store employee information, space, and then just like in ordinary SQL, after the table name, you then pass in parentheses, your column list and your data types. So we're going to create an ID column, pretty standard for a table. It uses the integer data type and has the primary key constraint attached to it. And if you've built tables in SQL, you should be very familiar with that. We'll also create a column called fn, and we're going to do varchar 20. Varchar is a variable length character string. They tend to conserve disk space more than just a straight text or char type. SQLite supports lots of different data types, including the binary large object, or blob, if you wanted to store binary data like audio, video, image files, etc. Finally, I'm going to do ln for last name, also varchar 20. We need to put an extra paren there to close the column list. Triple quote, close the execute method. All the gray tells us that we have a complete statement now, and we get a trace back. One nice thing about working in the interpreter is that we can always come back and repeat the last expression. You see what's happening here. I have an extra parentheses, so what I'm going to do is position my cursor before the next column, backspace up a couple times, and then press enter. Good and good. And you notice that it comes back by telling us we've created a cursor object, and this hexadecimal value you see as feedback in the Python shell is the memory location of that object. Now we have a table that's empty, so we need to add some data to it, don't we? We need to do the insert statement to add that data. As I told you, execute is our catch-all bucket for issuing SQL against a database and table. I'm going to triple quote string insert into emp values, open paren, and I'm going to carry this over to the next line so you can see what I'm typing. Triple quoted string allows us to do this. And then in parentheses, we're going to need to fill out data for all three of those columns, just like this. Now, are nulls supported? Yes. You can override that with the not null keyword. Could we also populate a row partially? Yes, just standard SQL, insert into emp, and then in parentheses the column or columns that you want to update, and then values, you do that. If you're doing the syntax I am, insert into emp values, that's going to require that we put something for all three columns in the emp table. Let me finish that triple quoted string. I'll tell you, friends, and you're going to see this for yourself once you start coding with SQLite, the biggest pain in the hindquarters here is not the syntax. As you see, the syntax is elegant and straightforward. The toughest part is just figuring out and remembering how many parentheses you've opened and making sure you close them at the correct spot. You can see here I've spent some time in the background with some tracebacks that are nothing else than syntax errors. Ay, ay, ay. Well, I'm glad I can, once I've finally put a row into this table, I can put my cursor back on it, hit enter to get it back, and then simply backspace to change my data. At this point, I've put in 2 rows into that emp table. Final thing we want to do is run some SQL. We're going to run 2 select statements to retrieve data. The first one is your traditional select splat or select star that retrieves all columns, all rows from that table. Once again, cur.execute, and then as a quoted string, we use our SQL, select star from emp. Actually, I might want to issue a commit, and the commit is a method not of the cursor, but of the database object. Locking in SQLite isn't as fine-tuned as you'll find in, say, Microsoft SQL Server that can lock a database at many levels. Here, the database is locked at the database level, and although this is a transaction-safe system, it's essentially in interactive commit mode, where you have to manually issue a commit statement, and that, again, is the connection object with the commit method in order to flush any changes you've made to disk and make them permanent. If you really want to be safe, you would want to issue a commit statement statement after each insert. In this case, I've issued one commit that would roll back a whole bunch of stuff at once now if we had an I/O error, for instance. Again, the notion of transactions and committing is beyond our scope, but be aware that commit is an important and required function in order to make your changes persistent in the database table. Now, back to our regularly scheduled programming. Let's go back to our cursor object and execute as a quoted string our select statement, select star from emp. Notice that that just creates another cursor object. We need to print yet another method. There's fetch one and fetch all. Actually, there's fetch all, fetch many, fetch one. If you want all the results of the query to come back, you'll pass in the cursor.fetchAll with open and close parens, no arguments, and you'll notice that the output comes back as a list of tuples. We have one row tuple, second row tuple. The last thing we'll do is issue a selective select statement, and what I mean by that is cur.execute. This time we'll select all columns from emp where the ID is equal to 1. You see, so you can just structure your SQL. You can use your sorts, your ascending and descending sort keywords. You can use your booleans and or not. All of that standard stuff is supported just fine. Let me close that string and let me fetch all again. And of course we just get a single row back this time. Final thing we do is formally close the database on the connection object, and that's by issuing con.close. Python and database access. At this point, now that you've reviewed this nugget, I hope that you're as excited as I am about how easy it is to link your Python project to one or more relational database management systems. You now should be familiar with what the DB API version 2 is, what APIs are in general, and where you need to go to get a head start on finding the appropriate connector between Python and your RDBMS of choice. Because it's so convenient, and also because it's bundled in the standard library, I showed you specifically how to connect up Python to SQLite. If you weren't really clear on what SQLite was before this nugget, you sure are now, and I hope, again, you're as impressed with this little guy as I am. I hope that this has been informative for you, and I'd like to thank you for viewing.